Ever notice how we tend to think about thinking as this like super straightforward process, like our brains are these perfectly organized filing cabinets, but then, that feeling when a new idea comes along and kind of blows up that whole neat system?
Yeah, those aha moments, those leaps in logic, they're what we're really digging into today.
And I've heard through the grapevine that you can usually find a paradox hiding behind those leaps.
Absolutely. A statement that seems to contradict itself, but somehow it can be true. It's fascinating.
Okay, so lay it on me. Paradoxes, AI, how scientists think. You've got a stack of research for us. Where do we even start?
Well, we've got some really interesting excerpts from William Wimsatt's Re-engineering Philosophy for Limited Beings, and there's this new concept, artificial fluency, plus a ton of research papers on AI and how our minds work.
So we're going deep into how these brain-bending paradoxes are being used to push the boundaries of AI. I'm here for it.
It really makes you question the traditional view of intelligence, both human and artificial. For so long, we focused on pure logic, on systems that were perfectly rational.
Right, like Spock from Star Trek. All logic, no emotion.
Exactly. But what Wimsatt points out, and what AI researchers are finding, is that human intelligence,
Mm.
it needs a little bit of messiness to thrive.
Wimsatt calls it the myth of Laplacian omniscience.
Oof.
Right. Had to look that one up.
It's a mouthful. It's this idea that humans can have perfect knowledge and make perfectly logical decisions. But Wimsatt argues that's just not realistic.
So we rely on mental shortcuts. Like it's more about knowing how to find the answers, even if we don't have all the information.
Exactly. Think about scientists. They don't have unlimited time or resources. They have to rely on intuition, experience, even biases sometimes to guide their research.
Like that story about Newton and the apple.
Hmm.
Did it actually fall on his head? Maybe not. But it sparked a connection. That's what led to his theory of gravity.
Exactly. And that's what's so cool about this new wave of AI research. Instead of trying to eliminate the messy parts of human thinking, they're looking for ways to build them in.
Makes sense. We don't need AI to play chess in a vacuum. We need it to operate in our world, which is messy and unpredictable.
And one of the most powerful tools we have for navigating that world is analogy. It's how we learn, how we solve problems, even how we understand abstract concepts.
So not just shoe is to foot analogies.
That's right. This is much deeper than that. Think about learning a new language. You come across a new grammar rule, it seems complicated, but then you realize, wait, this is kind of like the subjunctive in English, but with a twist.
You're using your understanding of English as a framework. You're drawing an analogy.
Exactly. And that's what's so fascinating about how analogy is being used in AI now. There's this technique called analogical prompting, where researchers are training AI to remember relevant examples to solve new problems more creatively.
Like giving the AI a nudge, saying, hey, remember that other problem? Maybe what you learned there can help you here.
Exactly. And it's working. AI systems are becoming more adaptable, better at handling new situations when they can use analogy.
Which leads us to symmetry breaking. I'll admit this one's a little harder to grasp.
It sounds abstract, but it's all around us. Imagine something perfectly symmetrical, like a sphere. It looks the same from every angle, right? But if you introduce even a tiny imperfection, boom, symmetry is broken.
So a tiny change can completely change how we see something. That's kind of wild when you think about it.
And it's not just physical objects. Our thinking works this way too. Those aha moments, the ones we were talking about, they often happen when we're forced to see a problem in a new way. When that initial symmetry breaks down.
Our brains are like, well, that old way of thinking isn't working. Time for a change.
And what researchers are finding is that when they intentionally introduce these shakeups into AI training, it leads to some pretty remarkable breakthroughs.
Hold on. So we're talking about intentionally confusing AI. I get frustrated enough when my computer freezes, I can only imagine.
Think of it less as confusion and more like a nudge toward creative problem solving. Remember we were talking about how our brains aren't perfectly logical?
Right, the shortcuts and the mistakes and all that.
Exactly. And sometimes those mistakes lead to unexpected insights. Researchers are finding ways to replicate that in AI by introducing paradoxes, even errors, into the training data.
Okay, I see how this is all coming together, but we've talked a lot about how our brains work, how AI is mimicking that. What's the practical application here? How do we actually build AI that can deal with this complexity?
That's where it gets really interesting. One really promising approach is something called domain-specific language models, DSLMs for short.
DSLMs, break that down for me.
Imagine you need an AI to analyze financial markets. You wouldn't want an AI that just understands language generally. You'd want one that's fluent in the language of finance, right?
Right, one that understands market trends and risk assessments and all the other stuff.
Exactly. DSLMs are all about specialization.
Hmm.
Instead of trying to create an AI that's good at everything, researchers are building models that are experts in specific areas: finance, medicine, law, you name it.
So, like giving AI a specialized education, a deep dive into a particular area,
Exactly. And what's interesting is that these DSLMs are really good at handling the messy, unstructured data that trips up more general AI.
because they're not just processing the information, they're actually understanding it, the context, the nuances.
You got it. It's like the difference between someone who's studied a language in a book and someone who's lived in that country. DSLMs, they're all about that deep immersion.
Okay, DSLMs, got it.
Hmm.
But even with human experts, there's always more to learn. How do these DSLMs keep up?
That is a great question, and it leads us to another fascinating area of research. It's called meta-learning of compositionality, MLC.
MLC. Okay, a lot of acronyms today. What's so special about this compositionality idea? MLC sounds like we're going meta on AI learning here. Is that about teaching AI how to learn instead of just what to learn?
You're exactly right. Think about how we learn new things as humans. We don't just absorb information, we connect it to what we already know. Break it down, reassemble it in our minds. That's compositionality.
We take these building blocks of knowledge, words, concepts, experiences, and combine them in new ways. That's how we innovate, solve problems we've never even seen before.
Exactly. And with MLC, researchers are trying to give AI systems that same ability. They're developing algorithms that allow AI to learn how to learn from just a little bit of data, to find patterns and use those patterns in new situations.
So instead of needing tons of data to learn a new task, AI with MLC could pick up a new skill from just a few examples, like a human apprentice learning from a master.
Great analogy. And it could change everything. Imagine an AI that can learn a new medical procedure just by watching a few surgeries, or a financial algorithm that can adapt to a market crash because it's seen the warning signs before.
So we're not just talking about AI that's faster or more efficient than us. We're talking about AI that can think in ways we haven't even imagined.
And that's exciting. But it's also a little bit daunting. We're in uncharted territory here. We need to be careful.
How do we make sure these advancements, these DSLMs and MLC, how do we make sure they're used for good to help people?
That's the million-dollar question. And it brings us to this idea of flow engineering. It's not just about building smarter AI, it's about building AI that shares our values.
So we're talking about ethical design,
Yeah.
making sure AI is used responsibly.
Exactly. Building in transparency and accountability from the ground up. Making sure these powerful tools are used to address real-world problems: healthcare, education, climate change.
Making sure AI doesn't just amplify our biases, but helps us overcome them. That it makes the world better, not just easier.
You got it. And the really fascinating thing is, it's not just a one-way street. As we teach AI to think more like us, to embrace that messy brilliance of human cognition, we might actually learn something ourselves.
So AI becomes a mirror. It reflects back on our own thinking, our own creative potential.
Exactly. We start to see that our ability to hold contradictory ideas, to embrace those paradoxes, to constantly question, it's not a weakness, it's at the heart of what makes us human.
And maybe, just maybe, if we watch AI learn to navigate a world full of paradoxes, we'll learn to navigate our own world a little better, with a little more creativity, a little more wisdom.
Wouldn't that be a paradox worth celebrating?
It certainly would. This deep dive has been amazing. I'm feeling inspired and a little mind blown, I'm not going to lie.